This video shows the requirements, the calculation and interpretation, effect size calculation, as well as reporting the results for the Mann-Whitney-Wilcoxon test in R. Its purpose is testing two groups for differences, or put more technical, if they originate from the same distribution or not. It is the non-parametric alternative to the two-sample t-test. For example, I want to test for the gender pay gap, meaning I have a fictitious sample of men and women and their respective income. The requirements for the Mann-Whitney-Wilcoxon test are the following: two independent groups and a dependent variable on at least the ordinal scale. As a first step after importing data, I want to see some parameters like the median or quartiles 1 and 3. Mean and standard deviation are fine too for a first impression. You can use the describe by function from the psych-package for mean, median and SD. I can see that the median for women is 2400 and for men 2875. The quartiles can be calculated with some piping based on the summarize function of the dplyr package. The quartiles 1 and 3 are also higher for men than women, giving us a hint of a possible gender pay gap. You can also visualize the income of the groups by using box plots and seeing the interquartile range represented by the height of the box and the median by the black horizontal line. Now I want to test whether the medians are significantly different from each other. For this I use the Wilcox_test function of the rstatix-package. Simply put the name of your data frame first and afterwards the dependent variable followed by tilde, that small wave symbol, and put the group variable behind it. Please note that the default testing will be two-sided, meaning you test for only a difference. In case you proposed in advance that your first group has a greater median than the second one, you can add the argument alternative equals greater. This works if you simply have numbers for groups. If you have names for groups, the alphabetical order is used. If you hypothesized a smaller median for group 1, use alternative equals less. I can now run this one line and get the results. If the p-value is below my predefined threshold, for example 0.05, the null hypothesis can be rejected. Reminder, the null hypothesis assumes no difference of the medians between the two tested groups. In my case, I defined alpha as 0.05 and can therefore reject the null hypothesis because my p-value is lower with 0.0282. Hence, I can conclude that the median income for men and women in my fictitious sample is different. After a significant Mann-Whitney-Wilcoxon test, an effect size should be calculated. It is common practice to calculate the effect size R for observed differences. R equals the standardized test statistic divided by the square root of the number of observations for the two groups that showed a difference. We can easily calculate that by using the Wilcox_f_size function. The formula you have to put in is the same as in the Wilcox_test function. You can see that in my example it is 0.309. Finally, you have to classify the magnitude of this effect. If similar studies in your research field exist, compare your effect size with the given ones. If no comparable studies exist, use the common thresholds within your research field though. If those are also non-existent, you can refer to Cohen 92, a power primer. Page 157 shows the three thresholds for the effect size R. If it exceeds 0.1, it is a small effect. If it exceeds 0.3, it is a medium effect. And if it exceeds 0.5, it can be classified as a large effect. When you're done, you have to write up the results. The output of the Mann-Whitney-Wilcoxon test in R usually consists of only the test itself, and in the case of an observed difference, the effect size R. First, one formulates whether the groups are different or not, providing medians for the groups. Following that, you need to report the standardized test statistic, which is derived from the p-value. For that, you can use the qnorm function and put in the halved p-value for a two-sided test. In case of a one-sided test, you'll use the normal p-value. Speaking of p-value, you also need to include this into your reporting. When you were able to observe a difference, aka an effect, report the calculated effect size R. Finally, the magnitude of this effect is classified with, for example, Cohen 92 or the respective research field specific thresholds.